Okay, we're looking at lesson 12.4, surface areas of pyramids. And when you think of a pyramid, I always think of the Great Pyramids of Egypt. So nice sandy background here in this picture. Once again, there is the pyramid. Over here, I don't think this is for real, but it's kind of a funky looking thing. I think it's supposed to be a building, but who knows? It's just nice to look at, and it is also, importantly, in the shape of a pyramid. Alright, let's look at some pyramids here. Hold on a second while I get you set up so you can see. Alright, we're going to zoom way out. I think I'm going to zoom out as much as I can go. One of our favorite pyramids. This has a base has six sides to it, so it's a hexagonal pyramid, or a lot of you like to say hexagonal. I will keep saying hexagonal. And all of the faces are triangles. Okay, prisms, all of your faces are rectangles. This is the difference here. And it comes to a point. Pyramids come to a point. So when you lay this out, oh, how pretty is this? You get a nice star-shaped thing. I know you can't see this very well, but there's your hexagon, and then you have these triangles. Okay, I'm going to turn this over for a second. This is, I know you can't see the entire thing, but you have the idea. This is your lateral area. All of these spokes, all of these rays of the hexagon, I guess you want to say, they're all triangles. All of these add up to be your lateral area. If you add in the base, surface area. We've kind of done this before. Surface area. And like now you just count the triangles, lateral area. Surface area, lateral area. All right, moving along here. If you look at this, you see that you have all these different parts of your pyramid. The vertex, that's this spot right here. This is your vertex. It's where all of the faces meet up here at the top. Lateral face, you have lots of little lateral faces. In this case, you have 4. Lateral edge is where your lateral faces will be meeting. Okay, so your lateral edge, right here, right here. There's one over here and another one back here. Those are your lateral edges. Altitude is how tall, and it has to go from the top, and it comes down here, and that's like the middle of the base. It forms a right angle with the middle of the base, by the way. And that's how tall, in other words, how tall does the garage have to be to park your pyramid? And then, of course, the base is the shape, and that's how you name this. This would be a square pyramid because the base is a square. All right, I have this picture of this other one down here. This is actually an oblique pyramid. Okay, an oblique means that this altitude doesn't come down right into the middle here. Okay, and it looks like somebody took the top of it and just pushed it. They said, I'm going to push that thing over. Okay, so the center is not, this vertex is not centered over the top middle. Okay. All right, just so you know it's oblique, we don't really have, I don't think, hardly any problems with oblique pyramids involved. All right, let's talk about how they come up with the formula, the lateral area of a regular pyramid. So we've already talked about the lateral area does not include this hexagon here. This part is out. Or not hexagon, that's a pentagon. All right? But we do need to add all of these triangles together. If you think about it, this triangle has an area of 1/2 base times height. This has an area of 1/2 base times height. 1/2 base times height. Oh my goodness, we can do it over and over again, and we can add all of these together. However, if we look closely, the base would be this on this triangle. And the base would be this on this triangle. And the base is here, and the base is here, and the base is here. So all of those are your base total, which is also known as a perimeter. Okay? So instead of saying all of these B's, And when we add them all up, let's just say 1/2 times the perimeter. And now let's look at the height. Wouldn't the height for this one be the same as the height for this one, and the height for this one, and the height for this one, and the height for this one? So instead of writing that, we're just going to take 1/2 PH. Now, you're like, Mrs. Talley, that doesn't look like what they wrote on the board there. You're right, it's not. Now, when we think about this, little bit right here, and I've got to go back to the picture because it's hard to see when it's flat, it's hard to see when it's not flat. If you look here at the height of these triangles, look at it, it's slanted. Okay, especially if I hold it up, but if I can't hold it up, then you can't see it. So slant, it's got a slant to it, right? So when we say the height of the triangle, it's actually a slant height. And why am I saying it funny like that? Because they choose a very interesting letter to represent slant height. It's the slant of the triangle. All right? And because they use L, I do not know why. All right, so you're going to have 1/2 P and then L. That is, I want to make this distinction here. This is like your altitude. This, the dotted line, is your slant height, and that is what we use on our triangles to find the lateral area. So lateral area for a regular pyramid is going to be 1/2 PL. P for perimeter, L for slant height. Okay? Now, same thing for surface area. We're going to take all of those triangles, but then, oh yes, we have to add in our base. Okay, so basically we're going to keep the lateral area plus the area of the base. Now, unlike the prism, you don't have 2 bases to add in, you just have 1. Okay, so your surface area is equal to your lateral area. Oh, yeah, we know what that is. That's 1/2 PL for slant height plus the base. The area of the base depends on what it is. In this case, it happens to be a pentagon. But in this case, it's a square. So that's why we keep capital B. And remind yourself that capital B stands for the area of whatever the base is. All right. And another video for the example problems. So you can move on to that.